Alright, so right now I am doing a quite long video comparing the the sea surface temperatures of 2016 and 2017, currently 2010, 2011, and 2009 and 2010. Now, first, I will do a comparison of this region of 2010, 2011, because some people are actually using this as an analog year. I mean, where some people are still thinking about it. So, I will note, as of currently, right now, there is one distinct similarity, and it's a very slight similarity. I will tell you that right now. This is a very slight similarity to what we have right now. Now, cross this out. This is nothing like what we have right now. We have cooler than normal temperatures in this region right here. But here is a very distinct similarity to what we have now. This right here. Also, we have that right. So, let me just circle the entire Atlantic Ocean. This is a very good similarity to what we have now, but except for, you can see you have bitter cold waters just south of Greenland, then you have warm waters all over Greenland. Matter of fact, these waters are warmer than they are now. But you can tell that the NAO just flipped to positive that winter. Actually, no, the colder waters up well in this region right here, not really a tripole at all. And many people are wondering, will this winter be similar to the one of 2010-2011? No. Just no. Because at this time in 2010, you can see that the PDO was cooling extremely fast too. So that's not a good sign if you want snow for the East Coast, because you would have you have much warmer waters here. Warm waters northwest of Hawaii signal troughing in the west and a ridge in the east, meaning that it's let me get rid of that real quick. Meaning that it's warm in the east and cold in the west. You now also have a negative PDO and quite a very strong La Nina. Now, the perfect signal of a La Nina, of a very strong La Nina, is if you have this. If you do not have this, then it's just a weak La Nina. Just take it as like triceps on your arms, okay? If you don't have big triceps on your arms are going to look tiny, because that's not a lot. There's not a lot there. So, you have a very strong and still strengthening La Nina. This is a very good sign for strengthening La Nina. Also, this region right here is a very good sign for a strong, strengthening La Nina. Now, just to draw what we have now, just get rid of this right here, turn this to warm, get rid of this, turn this to warm, and turn this to cold. I mean, not warm. Cold, this is cold, and you also have warm here. That's what you have now. Also, the Atlantic is looking actually very similar, but this one had a warmer west. It was warmer west of Africa than it is now. But you also had a signal of cooling waters here because you had this right here. Is that necessarily a very strong signal? No, but it's still a small signal. Looking here, you had very warm waters, and you had cool waters here, but this is just leftovers from 2009 2010, which eventually dissipated and turned in. The entire Gulf of Mexico was essentially shut down that year due to the La Nina. So just cross this entire region out. This entire region was dry. You had barely any snow for the East Coast. It was cold, you could say it was slightly below normal, but nothing brutal. Now, so you have all these signals, but one, as of August, pointing towards a cold winter. Now, you were also climbing out of solar minimum, and you were making a very fast climb out of solar minimum, meaning during the winter you had lots of sunspots. Sunspot activity determines whether or not the globe will be warm or cold. As of now, like currently, right now, it's looking like the globe will be cooling in the next few years because of solar minimum, which we are entering at a very astonishing rate, because I checked the current sea surface not sea surface temperatures. Let me show you right now. We currently have, as of August 22nd, well, this is dated, this is from yesterday, we currently have 2 sunspots on the sun. 2. Which, the sunspot is located here. We have here, and this one right here is very tiny, you can't see it, but it's still there. 2 sunspots as of now. Now I will be showing you a year that I think is quite similar to what we have this year. I will be showing you 2009 and 2010. Now, this is August 2009. Now, here is the main reason why I'm thinking that it is a similar year to currently. Once again, it is the Atlantic. First of all, you have let me just make this red. You have warmer than average waters west of Africa. Quite actually, it is warmer now than it was in 2009. So that is a very good check for colder and snowier winter for this region. Now, you have warm here. This is warm. Now, currently you have cool, but it's slightly warming. And now, this region right here is all dotted with colder than normal waters here, and you have 2 dots of it here. Now, you're starting to see cold gravitating towards the center, because you're seeing the Atlantic cooling down. Now, looking at Greenland only, you have she can't come in. She can't come in anyways. Oh. Well, so, excuse the interruption, but now you look south of Alaska. Are you seeing warmer than normal sea surface temperatures? Warmer than they are now? Yes, you really are. These are way warmer than you're seeing now, but it's just way warmer all around Greenland than it is now. Now, do I think this is still a good analog for this winter? Yes, I do. There are many differences. Well, there's a few differences to count. First, you were already in solar minimum, and you could already see the winter pattern in summer. You had a polar jet stream dipping down and then going up like this. Just like that. 100% just like that. In the summer. That is very unusual. This summer it's just been like this. Just straight west to east. No dips in between. You're seeing some troughing beginning to form, but nothing major. And now tropical activity is picking up in the Atlantic Ocean. Something to keep your eyes on. And now you also are seeing this. This is way different than what we have now. What we have right now is warmer than normal waters here. They have that too, yeah. But look at this region and look at this region. It is cooler, and it is showing very strong signals of cooling continuously. Now I will take you to what happened in December compared to August. Yeah. Now this is December, the winter month, the first winter month of winter. So, happening between those months is a negative PDO. So that's a no for a snowy winter. It's snowy and cold. But this is a gigantic check for a snowy and cold winter. This region right here. You see how strong that tripole is? It is so well defined. And as it has that winter, it started out in this region. And it migrated there. And now look west of Africa. As a matter of fact, it's looking as warm now as it was back in December of 2009. So this is just as warm as it is now, basically. Now, you can already see signals of a La Nina that's incoming for the next year, because you see that cold upwelling right there. Now, people are just taking 2016 and 2015 as like a signal that weather forecasters can't get winter right. Because, matter of fact, you had multiple cold signals pointing, and the models were pointing towards a cold winter, with jet stream dipping down and up. Turns out that almost the entire winter, you had one big storm that formed in the Pacific, riding down first as energy, and then it just blew up in the Gulf of Mexico, rode up, and exited off the benchmark. That's because you had a negative NAO, negative AO, a positive PDO, and the El Nino was weakening. That was, I believe, January 21st or 23rd. Either or. Now, people are taking that year as a very strong analog, so I will try to get that sea surface temperature map before I run out of time, just to show you. And I'll continue talking as this is going on. So, even the models were predicting a colder than normal winter for the eastern United States, but all of them, as a matter of fact, all of them were in sync with a colder than normal winter. And they were all wrong. The reason why they were all wrong is simply because the El Nino strengthened so much and so fast that they were just caught off guard. So I'll take you to winter, December 31st. Now save image, open, leave, because I have to edit it while I'm talking to you. So go to gallery. Alright, back. So now, this right here is what caused them to be 100% wrong on winter. So many people are looking at that as an example that none of these long-range forecasters can get anything right. Don't take that. No, that is not true. And basically the entire Pacific was warm, and you had this tiny little signal that was warning us of an incoming colder than normal Pacific ENSO region. But it is a very weak signal of a colder than normal. So I have to cover this very fast because I'm running out of time. Look south of Greenland. All cold. Not a very distinct band, just solid cold. That signals a positive NAO. This is a positive PDO, yes, and this is a very strong El Nino. The very strong El Nino just completely overridden all these factors pointing towards a cold winter, and that is what caused it. People were just forecasting a moderate El Nino. If these factors would be able to contribute, forcing the jet stream up north and then down south. But no, that was not the case, so it became tied with the strongest El Nino on record. So that is my forecast as of now. I will be back on Thursday. See ya later.